will learn the characteristics of particles of matter. The first characteristic is that the particles of matter have space between them. So we'll do a little experiment to show that particles of matter have space between them. So to go back to our experiment, here we have a beaker with water, and next to it we have some sugar particles, about 50 grams of sugar particles. Now we add the sugar particles to the water. So here is the water, and we are adding the sugar particles to the water, and you keep stirring it. Now what you observe is the level of water remains the same. It does not change. You would expect the level of water to rise up, but that does not happen. It is made up of molecules. So I have one molecules here, right through there are molecules. There are particles. Water is made up of particles. Matter is made up of particles. And this sugar molecules or particles are occupying the space between these water molecules. So hence the level of water will not increase. This clearly shows that there are spaces between the particles of water. If there were no spaces between the particles of water, the sugar molecules would not have occupied the spaces in between, and the level of water would have increased. But here the sugar molecules are occupying the spaces between the water molecules. So here I've drawn the beaker of water again with these molecules. These are molecules of water or particles of water, and we have the sugar molecules that have occupied the space between these water molecules, and hence the level of water has not increased. So we learn two things in this experiment, and the two properties are that number one, matter is made up of particles, and number two is the particles of matter have spaces between them. See, they have all these spaces between them. To explain that particles of matter are continuously moving, let's perform this experiment. Here we have again potassium permanganate. So this is a little potassium permanganate here, and it is added into a beaker of water. This is my beaker of water, and I've just put the potassium permanganate. I have not stirred it. Now here, after some time, I notice that this potassium permanganate, this pink color keeps spreading all over in the water. Remember, I am not stirring this. This pink color slowly spreads all over in the water. There's still water here, and the pink color keeps spreading. After a few hours, I see that all the water is now turned pink. Now, why has this happened? I have not stirred. How has the potassium permanganate spread throughout the water? So when potassium permanganate is added to water, do not stir, that's important. It turns pink. I will explain this in the next figure. So here I have a beaker of water, and in this beaker of water I have all these molecules of water, and in this I have added potassium permanganate. So here are my molecules of potassium permanganate. As time passes, these water molecules are constantly moving. They are not in one position. They keep moving in different directions. Yeah, they're all the time moving. So as they keep moving, they spread these molecules of potassium permanganate all over. See, like in this next one, have you seen, they even spread further away. They've been pushed by these particles of water, molecules of water that are constantly moving. So in the end, what did you get? You got this potassium permanganate spread all over in the water. So this goes to say that the molecules of water are not stationary. Had they been stationary, then this potassium permanganate would have remained in the same place that's here. It would have not moved from here. It is moved from here. It's because the molecules of water are constantly moving. They're constantly moving and they are pushing the potassium permanganate and spreading them all over the water. The third property is that the particles of matter attract each other. Let's do an experiment, or let's discuss situations which makes this clear. To understand this, let us take an example of iron and chalk. Now we see that iron, we cannot bend iron very easily. But when it comes to chalk, we can bend it and even break it very easily. So we cannot break iron easily, but chalk we can break very easily. Now why is that so? If we have two atoms or two particles of iron, there's one particle of iron here and another particle of iron here. Here one particle of iron, here's another particle of iron, and in between these two particles of iron there is a force. But however, in this case the force is very strong and so we can't break it. But if we take chalk, if we take one atom of chalk and another atom of chalk, and the force between these is not strong, it's very less. This force is very huge, very strong. Here the force is less. So since the force between the iron particles is greater than the force between the chalk particles, we can easily break a chalk particle, but we cannot break iron because there is a strong force of attraction between them. Hence we can say all the particles in matter, they are attracted to each other by a force of attraction. So here if I have like an atom here and I have another atom here of any matter, another atom here, an atom here, so this is matter, and there will always be a force of attraction between these two, between these two, between these two particles, between these two particles, between these two, this two, and so on.